Hey everyone, welcome back. I'm your physics buddy, and today we are moving from circuit logic to circuit power. In our last two lectures, we have mastered how to find current and voltage, but today we are assuming the most important question: how much work is that circuit actually doing? Welcome to the lecture 3 of Unit 11. We are diving deep into electric power and device efficiency. We'll break down the three different areas to calculate power and, more importantly, how to calculate exactly how much energy is being wasted versus used by finding the efficiency percentage. If you haven't mastered the Kirchhoff's law or Ohm's law from the previous two videos yet, make sure to check them out first. You'll need those current and voltage values to get your power calculations right. Link to the full Unit 11 playlist is in the description.
What is power? Let us try to understand it once. It's a very basic term, and power is something which is defined as rate of doing work. Like how much work a particular appliance is capable of doing, it is defined by power. So power can be written as dW by dt, or you can say work done per unit time. Now just think about it. How can we write work done for any appliance doing some work? How can we define that work? So in order to do that, we have already came across so many relations. Like let us see a relation related to the charge. So what we know is that potential is nothing but work done per unit charge. From this particular relation, we can say work is nothing but potential into charge. If we substitute the value of potential here, substitute the value of work in this equation, we'll get power as it is nothing but d by dt of v times charge. So potential is something which is a property of battery which will remains constant. So inside we are left with dq by dt. Now we already defined current, that current is flow of charge, rate of flow of charge. So that dq by dt is nothing but it is current. So power can be written as vi. This is one such relation. Again from Ohm's law, we have another relation here. As we know, V is nothing but IR. So if we substitute the value of V again in this equation, we get power as I square R. So these are the few relations for power that we might be using in this particular assignment. So as you said, question number 39, right?
Yeah.
So let's start with question number 39 only, and we'll be using these particular relations only, nothing else. The question says an electric water heater is designed to produce 50 kilowatt of heat. So power is given here. It is 50 kilowatt. When it is connected to 240 volt source. So potential is given as 240 volt. So you need to write power in watt only, which is 50,000 watt. And this 50,000 watt power is there when it is connected to 240 volts of source. So question is, what is the resistance? How can we find out resistance here? So in order to find out resistance using these two given things, so let us see. Power is simply defined as V into times I. If we try to write I, so here we can say I can be written as V by R. So let us simply substitute this in place of I. So V is equals V into V by R. So it is going to be V square by R. So power is going to be V square by R. So I can say resistance is going to be V square by T. You can simply solve it. 240 times 240 divided by 50,000. This will give you resistance of that given appliance. So you just have to solve it now. Solve it and tell me what is the value of resistance here. This is like as simple as this. That's it. So solve it and tell me what should be the value of resistance. So does this make sense? You need to
1.15.
remember.
Yeah, 1.15.
Okay. So you just have to remember that how power can be calculated. The first relation we have is P is equals to potential time current. Second relation we have is P is equals to I square R. And third relation we got is P is equals to V square by R. So these are the few relations that we need to remember in order to calculate power for any given circuit. Let's move ahead. So next question you said is 40, right? Next is 40.
Yes.
All right. So question says if the heater in exercise 39 is 90% efficient, what does it mean? It means that the heater which we were talking about in this particular question is 90% efficient. 90% efficient means that the power it is going to have or it is going to produce, it is 90% of the value it is going to use. Like for example, suppose there is a appliance and that appliance is capable of doing work by using hundreds of joules. Like the power intake is 100 of joules. But what should be the efficiency? If efficiency is given, so how much work it will be able to do? It will be able to do 90% of whatever energy it has used. This is what efficiency is. Or you can say efficiency is something which is defined as efficiency is something which is defined as output power by input power. Like for example, how much power we have given to the circuit and how much output we got from it. So efficiency is defined by this particular relation. So make sure you remember this relation as well for efficiency. So here it is given as the efficiency is 90%. So 90% must be equals to output power by input power times 100. Now, what was the input power? How much power we have given to the circuit, or it is there in the 39th problem. It is 50,000 watt. So here we can say it is going to be 90. Now if it is percent, so you can write it as 90 over 100. What is output power? This is something we have to calculate. What is input power? It is 50,000 into 100. So if we solve it, we'll get output power as 90 into 50,000 over 100 into 100. So this will give us output power, which is going to be what? Which is going to be 450 watts. Like this means that whatever total value of power is there, it must have lose some power, and I should write it as 90 into 50,000 by 100 only. So this will give us 45,000 watts of output power. Now, what idea we got from here is that whenever there is a efficiency given in any case, you have to find out that how much it is going to do work. So this is the power with which it is going to do work. Now the question is, it is 90% efficient. How long would it take to heat 50 gallon of water from 20 degrees Celsius to 80 degrees Celsius? Like how much it is going to take time, how much time it is going to take. So how we have defined power? We have defined power as it is nothing but work done per unit time. So how much work it is going to do in a given time, it is something equals to power. So what is the efficiency? It is 90%. So we got 45,000 as the power. So 45,000 watt must be equals to work done upon time. Now this is the time which we have to find. So time is going to be work done upon 45,000. Now what you have to understand here is that how we can find out the work. How can we actually find out works? Now what is work? That is what we have to see. And what we have to here we have to understand. So heating 50 gallon of water. So first of all, what is 50 gallon of water means? 50 gallon of water means we have given the volume. So how can we write it down? Tell me, think about it. One more thing you have to understand here is 50 gallon of water is given here. If you try to convert the same thing into kilograms, we need to understand this fact that 1 gallon of water is approximately 3.785 kg. So 50 gallon of water is going to be 50 times this. So this will give me the amount of water we have present here in this situation. Now just think about it. How can we find out time? How can we calculate the work? So we got the weight of the water in kgs as well. Now think about it. So we found few relations in the last class when we were talking about resistance. So what we told that resistance is something which is rho L by A. This one was the formula we studied. Apart from this, we talked about one more formula which involves coefficient of linear expansion. Remember this one, this relation? Tell me, do you
Yeah.
remember this one?
Yeah.
So if we want to heat 50 gallon of water from 20 degree to 80 degrees Celsius, what should be the factor which is going to change? Think about it and tell me. Which factor should change?
The T value.
That is going to be the temperature. That delta T is already with us. Think
Okay.
something else, like think about this question once.
Alpha.
This is alpha is for water and it should be known. So we don't have to think about it. Uh, we have to
Arc
find how much
resistance.
time it will this particular thing will take to heat the whole thing. One more relation I'll let you know. So basically power and heat has a relation. As we talked that power is nothing but I square R, right? Heat is defined as power times T. So heat can be calculated as power and in place of power we can write I square R. So this is again one such relation. That much heat is required to do the change. So think about it.
Okay. It would be the resistivity, right?
R is the resistance.
Yeah.
Hmm.
Yeah. I'm not sure.
So what you can understand from this particular section is see, there are two ways.
Okay.
Suppose there is 50 gallons of water and it was initially at 20 degrees Celsius. Now we have to convert the same into again 50 gallons of water only but at 80 degrees Celsius.
Mhm.
So what are the things involved here? That is what we need to understand. First, there must be some heat that is needed to be given to this particular system and that heat is calculated using specific heat capacity, which you have learned in thermodynamics. So you have to keep those points in mind also, which you have already done, and that is how it is going to be calculated. So what we are going to do is we'll simply say that the heat energy, that is Q, is calculated by mc delta T. Remember this relation? You saw this relation in thermodynamics. Let me just
Mhm.
give you the idea. This m is the mass, this C is the specific heat, and this delta T is the change in temperature. So for water, we know each and everything, and we can definitely directly find this value out, that what is going to be the Q. So here this Q is going to be 50 gallons of water. We already found it is 189.25 kgs. Now, what is the value of specific heat for water? That is something you need to remember. Specific heat for water is 4184 joules per kg. In most of the cases, it is not given in the question because examiner assume that we know this value well. So we'll try to remember this. So 4184. Apart from this, how much temperature difference is there? It is of 60 degrees Celsius. So we can simply write it as 60. So the heat we are going to get is after solving all these things. Just tell me and let me know what should be the heat.
Okay.
See, whatever you have learned in the previous chapters also, you just have to keep this thing in mind that that too can be used in upcoming sessions. So whatever we have learned so far, like whatever chapters you have learned so far, just make sure that you remember each and everything. Everything is required. So here the Q will be approximately, I can write as 47508420 joules. This is going to this is going to be the value we are going to get. So if I try to write it as if I try to write it in megajoules, I can write it as well. That 47.5 megajoules. Because 47.5 times 10 to the power 6, I can write here. So that 10 to the power 6 is something which is referred as mega. So the heat which is required to do this process is 47.5 megajoules. So it is not a small amount of energy that is required to raise the temperature. But yeah, we need to understand that this 47.5 joules is the energy which is required. Now, as I told you, this relation that heat is also equals to power times T. So we have to find out time here. The time is going to be heat times power, right? Heat is 47.5 megajoules power, which we already calculated in the previous question, as per the efficiency, it is 45,000 joules, 90 because it was 90% efficient only. So heat is going to be 47.5 megajoules, whereas power is going to be 45,000 watt. Now we have to write these relation, like see how this watt, or you can say power, is something work done upon time. So it is not only watt, it doesn't only have the unit watt, it also have a unit joules per second. So here in place of watt also we can write joules. Now let's simply write what actual value we have and what value of power we have. If we solve this particular relation, that is 47508420 divided by 45,000, we are going to get answer for the time, like for how much time it is going to do. So it is going to do it in 1055.7 seconds. This is what this times means. This is how we are supposed to find out time. So it's not an easy problem, it's a little tricky one because here you have to actually understand what you have done in the previous chapters, units as well. And you need to understand the importance of efficiency whenever there is an efficiency given in any question for any device, how efficiency is being used to calculate the output power. So remember this relation as well. In this session already we have came across so many relations. Let me just let you know once again. First, we define power. That what is power? Power is nothing but work done upon time. It is also called rate of doing work. That how much work a machine or an appliance is capable of doing. Then we talked about few variations in this formula. So this is the one formula that you need to remember. This is the second formula that you need to remember. This is the third formula that you need to remember, and this is the fourth one. These all are for powers only. So apart from these formulas, we don't have any different formula for calculating power. Then this is also another relation that you need to remember for efficiency. It is very important. From here also, this is another relation that you need to remember. Apart from this, the final one. So these are the few relations that we got for power and heat and work related quantities. So just make sure you write these formulas and try to use them well in the upcoming
Okay.
questions as well. So what was the next question? Did you understand this particular question?
Yeah, kind of. Yeah.
Remember the each and every step, and if you remember the each and every step, you'll be able to do this. And one thing that I need to mention here as well, this particular section where we calculated heat energy, this is a part of thermodynamics. So this is something which you have already studied, so you need to remember this. This is called heat energy. This is called specific heat energy to be precise, which is calculated by mc delta T. So have you learned these things in the thermodynamics?
Yeah.
All right. So let's move ahead. Let me just tell me which next question you want to discuss.
Okay. I think 46.
All right. So 46th question. Let's see. Again, whenever you are starting any question, just make sure that you write whatever is given in the question. So question says a 200-watt computer power supply is on 10 hours per day. So basically we have a device, you can say, which is operating at power 200 watt, and it operates for 10 hours. So we have given time and we have given power here, that how much time it is being operated. So the question is, if the cost of electricity is 0.15 cents kilowatt per hour, so what does it mean? It means that the rating, or you can say the value of electricity is given here, that how much energy, how much money is required to get that 1 unit of electricity. So 1 kilowatt hour is basically the unit of electricity. You must have seen your electricity bill. So in that electricity bill, how much energy we have consumed, it is written in kilowatt hours. So that is the unit of electricity. You need to remember this. So question says for 1 kilowatt per hour, the government charges or the electricity company charges us 0.15 dollars, you can say. So question is, what is the energy cost to the nearest dollar if this computer is used likely this for a year? The question is how much energy or how much electricity bill it is going to generate if we are going to use the same computer with the same process for 1 year. So let us see how can we calculate this? How can we calculate the time? So first of all, we have to understand that how much power it is going to consume for each day. Like what we're going to do is we're going to calculate power consumption. This is the first part. First of all, we're going to calculate the power consumption by this computer in 1 day. So whatever power consumption we got for 1 day, we simply multiply the same power consumption for 365 days. And we'll try to calculate the power consumption in this particular unit only, that is kilowatt hour. Let me just break down this kilowatt hour. This is very important to understand. So 1 kilowatt hour is equals to 1. Like what is kilowatt? Kilowatt is 1000. What is hours? If you have to convert the hours into seconds, like if you have to convert hour into seconds, you have to multiply the same thing by 3600. So this will convert the whole thing from kilowatt hour to joules second. So it is going to be 3.6 times 10 to the power 3 joules second. So this is what 1 kilowatt hour energy equals to or equivalent to 3.6 times 10 to the power 6. It should be joules second. So this is the first thing that we need to understand first. Now let us try to calculate how much energy it is going to consume or how much power it is going to consume for this particular thing. So think about it. How can we do this?
Okay.
Hmm. You have studied power well now. You just have to try to find it out that how much energy it is going to consume in 10 hours.
Okay.
So you simply have to calculate this. You have to calculate the energy.
Okay.
So power consumption is 200 watt. If you have to write it in kilowatt, it is going to be 0.2 kilowatt. It is operating for 10 hours. So it is going to be 0.2 times 10 hours, which is going to be 2 kilowatt hour. This is the energy consumption for this particular computer in 1 day. This is what you need to understand. So if in 1 day it is consuming 2 kilowatt hour energy, how much it is going to consume for the entire year?
Multiply by 365.
Yes. So total energy is going to be 2 times 365, which is going to be what? Tell me.
730.
780.
730.
Okay, yeah, 730. So this much energy is going to be consumed for the entire year. Now we know one thing that for 1 kilowatt hour, the charge is 0.15. For this much kilowatt hours of energy, how much company is going to charge? Tell me.
Multiply this by cost of energy.
Yes, which is 0.15. So we have to find the answer to the nearest dollar. So just tell me what should be the answer here.
Uh, 109.5.
So this much electricity bill we have to pay for the entire years of consumption of electricity. Does this question make sense now? See, power related questions are generally like that only. They'll ask you that how much energy is used, how much energy consumption is there, and something like that. So you just have to explore all the relations and you just need to understand that what we are going to use. If you understood this particular part, you'll be able to do this. So this is the first part of this question. So we just find out that how much energy cost is there for the entire year's use of computer, and we got it is 109.5. All right, let's move to the second part. The question says, if this power supply is replaced by more efficient 100-watt version and it costs $75, how long will it take the decreased operating cost to pay for this power supply? Now the whole scenario has changed. What this scenario means here is, let us try to understand. So question says that now our computer has become more efficient, and because of that its power rated has changed from 200 watts to 100 watts. So if we try to write the same thing in kilowatt hour, it is going to be what? 0.1 kilowatt hour, right? The question says that it costs $75 only. Like, so the power supply, when it be replaced by 100 watt, so the energy which was initially what? 30, it cost $109.5. Now it has reduced to $75 only. So let us read the question once again. If this power supply is replaced by more efficient 100-watt version and it costs $75, how long would it take the decreased operating cost to pay for this power supply? Okay, so question says that we have replaced the power supply from 200 watt to 100 watt, and question is saying how much time will it take to recover this $75 cost of this power supply? How long will it take the decreased operating cost to pay this power supply? Let us understand how can we do this. Now, what we have to understand here is that the power supply has changed from 200 watt to 100 watt. So operating time will remain same. We are again going to operate it for 10 hours a day, right? So if we're going to operate it for 10 hours a day, how much energy it is going to consume, we can find it out. So energy is going to consume is power times time. Power is 0.1, time is 10 hours. So it is going to be 1 kilowatt hour. So we know cost of 1 kilowatt hour energy is 0.15. Now, if it does for 365 days, the total energy is going to be what? Tell me.
Times 365.
Which is equals to 365 times 0.15, like that. So you can simply multiply these two things and tell me what we are getting. How much cost?
Mm, 54.75.
$54.75. So this is going to be the cost if the power supply has changed from 200 watt to 100 watt. Now you can see the difference. Initially it was $0.109.5 and now it is $54.75. What does it mean? It means that we have saved almost $55 of cost of electricity by simply changing the power supply from 200 watt to 100 watt. So the question is, how much time will it take to recover the $75 cost? So I can say within 1 year we'll be able to recover $55, and maximum within next few days also, next few months also, like maybe in 15 months we'll be able to recover everything. Let us calculate the precise answer, that how much time will it take to recover that $75 from this particular bill saving. So initially it was 109.5, now it is 54.75. If we just subtract these two terms, we'll be having it is going to be 5, 7, 4, 4. So 44.75. This much of energy, this much of amount has been saved throughout a year. 1 year saving, you can say. This is 1 year saving. So for 365 days, we saved $44.75. And $1 is saved in 365 by 44.75 days. We have to save $75. So $75 is being saved in 365 by 44.75 times 75 days. If you solve it, you'll get the time, precise time, that how much days is required to save $75 to recover the cost of our appliance. Did you understand this question? Tell me, did you got this? Did you got this one, Arnav?
Yeah, I did the brackets wrong. 1 second.
Okay.
611.73.
So within almost, you can say 15, 17, 18 months, we'll be able to cover the cost, that cost, which is $75. So that is what we have to do in these kind of
Okay.
questions. I hope this question makes sense. Yes.